Hello Indonesia, my name is Jonathan Limantoro, Mahasiswa Berprestasi from Universitas Surabaya. For pemilihan Mahasiswa Berprestasi Nasional, I would like to present to you my research, a comprehensive quality evaluation system for Sauropus androgynus or katuk plant based on Morphometric, Metabolomic, and Genomic approach, as a way to assure the quality of herbal medicines to achieve United Nations Sustainable Development Goal, especially the third Sustainable Development Goal, which is the good health and the well-being of the people. According to Riskesdas in 2010, 55.3% of Indonesian people consume herbal medicines to stay healthy. And 95.6% of those people believe that the herbal medicines are very effective in doing so. Unfortunately, the huge increase of consumption of herbal medicines also pose a great risk, where a lot of herbal medicines are easily adulterated. In this case, adulteration means that the plants that are supposed to be the herbal raw materials are substituted or switched with another plant that is physically similar but possess a far inferior chemical and pharmacological properties. And the most severe adverse effects that this adulteration may cause is multi-organ failure and even death. Therefore, an authentication process is very crucial to assure the quality of those herbal raw materials. Traditionally, the identification process of herbal medicine is carried out according to differences in morphological characteristics or chemical marker identification. But this identification process turns out to be time-consuming, partial, and even unsuitable for a comprehensive quality evaluation of herbal raw materials. Therefore, here we employed for the very first time, to the very best of our knowledge, an integration of Morphometric, Metabolomic, and Genomic approach as a comprehensive quality evaluation system to authenticate herbal raw materials. The purpose of this research is to design a faster and more accurate system to authenticate raw herbal materials by integrating three different approaches to create a comprehensive quality evaluation system. The first approach is the Morphometric approach, which is a study of size, shape, and structure of the internal and external appearance of a plant. Second, the Metabolomic approach, which detects and analyzes the metabolic profiles inside of a plant. And third, the Genomic approach, by using DNA barcode, a short standard sequence of the DNA, to differentiate one plant with the other. In this research, we are going to use katuk plant or Sauropus androgynus, because katuk plant cannot only be authenticated based on morphological analysis or chemical markers alone. Therefore, it is a very suitable model to represent other plants to test the system that we are going to design. If the comprehensive system are going to be applied to katuk plant and it actually works, it can also represent other plants and also be applicable for them too. The morphological characteristics were recorded on several different quantitative traits, for instance, the plant height and the dry mass. The identification of individual chemical components was analyzed using gas chromatography mass spectrometry, or the GCMS. The mass spectra of each unknown peaks was then compared and selected based on the database and the similarities. The total DNA was isolated from leaves of katuk plant. The internal transcript spacer, or the ITS region, after being isolated, was then amplified using the primers ITS5 and ITS4. The amplified ITS region was then purified and then sequenced. An integration of Morphometric, Metabolomic, and Genomic approach was developed to design a rapid and precise system to authenticate herbal raw material comprehensively. The data from each approach will then be analyzed using correlational statistical analysis to see the correlation between each approaches. Different groups will then be analyzed by using the one-way ANOVA test and followed by Takis post-hoc analysis. A heat map is constructed with using the heat map 2 functions of the RGPlots package and then using the principal component analysis to be applied to all datasets to see the similarities between the tested cultivars and also to find the main variables that is related to the similarity. And then using the self-independent modeling class analog to assess whether the new sample actually has similarity with another sample or to which group it belongs. In conclusion, it is necessary to design and develop a quality evaluation system to authenticate herbal raw materials, to assure their pharmacological effect and the consistency of the final product's safety and quality. using SIMK algorithm to effectively identify a new sample belongs to which uniquely allocated one class that showed similar morphological, genomic, and metabolomic profile. Finally, we must remember that the reputation of jamu, or Indonesian herbal medicine, is based on quality. And quality rooted on our responsibility to provide a faster and accurate method to authenticate raw materials for herbal medicines, to assure that every person has access to safe and effective herbal medicines to cure and prevent their sickness, to achieve United Nations Sustainable Development Goal, especially the third goal, the good health and the well-being of the people. So Indonesia, I am Jonathan Limantoro, Mahasiswa Berprestasi from Universitas Surabaya, and I'm very proud to support the Sustainable Development Goal. Thank you.